Okay, this is lesson 4, parts of a fraction, as well as adding and subtracting fractions. So please make sure you follow along. If you have any problems, pause and feel free to pause and rewind the video at any time if you don't understand something. Once again, please feel free to ask me questions if you're still confused. So let's first go through the parts of a fraction. So we're there at the very first section, parts of a fraction. So the top number is known as the numerator, and the bottom number is the denominator. A rational number is a number that can be written as the ratio of two integers. So really this is a ratio problem. There's 5 of 6 in this specific example of a fraction. And that's pretty much, all of these are minor little, they are all small division problems. So if you ever need to turn a fraction into a decimal, always divide the top number by the bottom number. So it would be 5 divided by 6 in this case. Next part, the simplest form of a fraction. Simplest form is a fraction that cannot be simplified any further. And we'll go over some examples here of what that means. So if we look at the example of 4 over 30, or 4/30ths, I need to figure out what can I reduce that to? What is the smallest numbers I can use to represent that same quantity? So I look at the numerator and the denominator. A lot of times it helps to start with the smaller number. Well, 4 is the smallest number. I know I can either multiply 1 times 4 or 2 times 2 to get 4. So there's 3 numbers there. There's a 1, a 2, and a 4. Those are numbers used to get 4 if I multiply. 30, if I look at 30, what numbers can I use to make 30, to multiply to get 30? 1 times 30, 2 times 15, and 6 times 5. Oh, and 3 times 10. Well, the only number that came up in both of those, not counting 1, I don't ever want to use 1 because that won't reduce a fraction. The only number that came up both times was a 2. So really what I want to do, I might erase that, is now I want to divide the numerator and the denominator by that number that came up both times when I was looking for multiples of that number. Well, 4 divided by 2 is 2. 30 divided by 2 is 15. Then I look at that again and I go, well, I can't reduce that any further because the only number that I can take out of 2 or that multiplies to get to is 1 times 2, and 2 does not go into 15. So that's as low as I can go. Same thing with number 2. Now you might notice right off the bat there's a little negative sign out there. Well, this goes back to multiplying and dividing integers, and there's only 1 negative, so that means my answer's got to be negative. So keep that in the back of your mind. My answer's got to be negative. So I look again. I've got a 2. What 2 numbers do I multiply to get 2? Well, it's only 1 and 2. 1 times 2 gives me 2. What numbers can I multiply to get 14? Well, there's 1 times 14. I don't want to use those because 1 doesn't reduce anything. And 2 times 7. Okay, there's 2. 2 times 7 and 1 times 2 both have a 2 in it. So again, if I divide by 2 on top and bottom, 2 divided by 2 is a 1. 14 divided by 2 is 7, and it's going to be negative, okay? It's a negative answer. Moving on to number 3. 15 and 40. Well, I'm looking through this and thinking, okay, if something ends in a 5 or a 0, I know 5 can go into it. Okay, well, 5 goes into 15 and 40. So I'm going back and remembering my multiplication tables. What number can I pull out of 15 and 40? So I know 5 goes into both of them. So I'm going to divide by 5. And the reason why we're dividing, if you notice, every time we do this, 2 over 2, 5 over 5, 2 over 2. Well, what are those numbers divided? 2 divided by 2 is 1. 5 divided by 5 is 1. I'm really dividing the fraction by 1. And whenever you divide by 1, it doesn't change anything. Okay? So let's keep going with this. 15 divided by 5 is 3. 40 divided by 5 is 8. And then I double check it. Is there any number that goes into 3 and 8? The same multiple. Well, the only numbers I can multiply to get 3 are 1 and 3. 1 times 3 and 8. There's no 3 in 8. And I don't care about the 1 because 1 won't reduce. So that is my final answer, 3 over 8. Let's go to this one. Sometimes you gotta go in baby steps. I'm going to look at number 4 and go, okay, those are both even numbers. So I know 2 goes into both of them evenly. So I'm going to try that one first. So I need to divide by 2, divide by 2. So that gives me, and remember, there's a little negative over here. There's one negative. That means my answer is negative. 22 divided by 2 is 11. 34 divided by 2 is 17. Those are not even, so I can't take 2 out of them, and there's nothing that goes into 11 and 17 that I could divide them both by and still get a whole number once I divide it. So that's my final answer, that negative 11 over 17. Sometimes these look kind of difficult. A lot of times they're really not. This one, I'm just going to look at it and go, okay, they're both even numbers. I'm not even going to mess with anything else, because sometimes if you can just pull a 2 out of it, that's what I'm talking about, is when I say pull a number out, I just mean what number can I multiply to get the top and the bottom number, using that number. So 10, I know we got 1 and 10 and 2 and 5. Well, it doesn't look like 5 goes into 62 and 10 doesn't go into 62. 5 doesn't go into 62, but I know 2 does. So I'm going to divide by 2 on the top and the bottom. You always got to divide by the same number when you're reducing fractions. And remember, there's this little negative out here, so that means my answer is going to be negative. 10 divided by 2 is 5. 62 divided by 2, well, half of 60 is 30. Half of 2 is 1. Negative 5 over 31. I can't reduce that anymore. There are no numbers that I could divide those by that would be the same number that would come out of both of them, because there's only 1 times 5, and 5 doesn't go into 31, and I don't care about the 1. So why don't you go ahead and pause and try the next 4 problems on your own. Okay, next part, improper form, an improper fraction. This is a couple of definitions we got to write here. Well, an improper form of a fraction is a fraction in which the numerator is larger than the denominator, is larger than the denominator. Okay, none of our previous examples up here were like that. All of them had a smaller number in the numerator and a larger number in the denominator. Improper would be a larger number in the numerator and a smaller number in the denominator. Mixed numbers. Mixed numbers means a whole number paired with a proper fraction. Fraction. Okay. So that just means a whole number paired with a proper fraction. So let's go through a couple of examples down here. Okay. Directions. Number 10. Write each improper fraction as a mixed number. Well, all I need to do is figure out, because these are mini division problems. All I got to do is see how many times does 4 go into 16. So I do 16 divided by 4. Well, I know 16 divided by 4 is 4. That's really a whole number right there. 16 over 4 is just 4. Let's look at number 11. I need to figure out how many times 16 goes into 28. Well, we got to remember there's that negative out there. That negative comes first. 16 goes into 28. I know only goes 1 time. And if I take 16 out of 28, that leaves me 12/16. Okay? but I can reduce that. I want to make that a proper fraction on the right. The 12/16 needs to be reduced. So I still have a -1. The 12/16 can be reduced because I know 4 will go into both of them. 4 goes into 12 3 times, and 4 goes into 16 4 times. So there's my final answer. Let's look at number 12. Well, cool, it's positive. There's no negative on there. 18 divided by 5. I know 5 goes into 18 3 times. And 3 times 5 is 15. If I take 15 out of the 18, that leaves me with 3. I get 3 left over, and I still have 3 of the 5 left over. And I can't reduce that. There is no number that goes into 3 and 5 that's the same number other than 1. And again, I don't want to divide by 1 because it doesn't do anything for me. Go ahead and pause the video and try to do 13, 14, and 15 on your own. Okay, write each mixed number as an improper fraction. Okay, so all I want to do is multiply and then add. So 2 times 19, 9 times 2 is 18, plus 2 is 20, and I still have a 9 left. Okay? Same thing over here. I've got a negative, so my answer's got to be negative. 3 times 5 is 15. 3 times 5 is 15, plus 1 is 16, so I have 16 thirds. 18, same thing. 7 times 3 is 21, plus 3. So that gives me 24 sevenths. Pause the video and try those next 3 on your own. Hey, you